February was Black History Month. And interestingly enough, March is Women's History Month. So yes, Dr. Kibia, there we go. This is a month where we recognize all of the women who have not only made important historical contributions, but have been important to us in our lives and maybe broken some barriers and are, in professions now that they were not as well represented in for some strange reason in earlier times. So the article I came across, so February, Black History Month, March, Women's History Month. And I read an article about the Tampa Bay Buccaneers. So I'm not a huge football fan, but the Tampa Bay Buccaneers, what's interesting about them is their coaching staff. It's an NFL football team, a professional football team, and the coaching profession in professional football has very historically been male and white. So the head coach of the team is a white man. The next 4 assistant coaches, like the highest assistant coach positions, are all Black men. The Tampa Bay Buccaneers have 4 full-time assistant coaches who are women, and that's the most in the NFL. One of them in a position that you may not connect, which is the strength and conditioning coach. And what did the Tampa Bay Buccaneers recently do? Oh, yeah, they won the Super Bowl. So I'm not saying they're directly connected and it's going to happen every year because they had a pretty good quarterback. But my point is that, you may not be limited in your success if you, think outside the box and provide opportunities for people who may not have had opportunities in those areas before. So I do think there's a lesson learned in being forward thinking and in being diverse and all of those things. So I read that article and it immediately popped into my mind. February, Black History Month, March, Women's History Month. Isn't that interesting? And then we've got a guest today. So that's enough out of me. So I'm going to hand it over to Ms. Hall, perhaps, or to our special guest. Hannah, thank you so much for taking the time to be here, talk to our 6th graders about science. So that's it from me. I'm going to mute my mic, and Ms. Hall or Hannah, whatever you may need, please let me know. Thank you again, Hannah.
All right, my friends, I am very excited to introduce our speaker. So our speaker is joining us virtually from California. So Hannah Dion Kirshner is going to speak to us today about climate science and geobiology. So Hannah is studying at the California Institute of Technology in the Division of Geological and Planetary Scientists. So I'm going to ask that you give her a round of applause through American Sign Language like this. All right, Hannah, take it away.
Thank you. Do you mind if I share some slides quickly just to show some photos? Great. Give me just 1 second to get it set up. How does this look? Let's see.
Looks perfect.
Okay. Great. And now I can see everyone else too. Okay, so I'm super excited to hear all the questions that you have to ask me. I thought before we get started with the questions, I would just give you a little bit of an idea of what my background is and what I do. So I am originally from Milwaukee, Wisconsin. And when I was your age and when I was in high school, I actually did not think I was going to be a scientist. I knew that I really loved reading and writing and teaching and being really creative. And so I actually wanted to be a musician. So I went to college to study French horn performance. But in my first year in college, I took a writing seminar that was on the topic of how different chemicals affect the environment. And that was the first time that I really realized, just as sort of luck, that this was something I could do for my job, that I could use science to understand the environment, which was something I had always really cared a lot about. And so I ended up changing my major and majoring in earth science. And so what I really loved about this job is that it allowed me to use all of those skills that I loved growing up. I do all kinds of reading, writing, and teaching all the time as a scientist. And I also get to think creatively and to work with my hands as well as my brain. And I really love this job because it allows me not only to spend time working in the lab and reading and writing, but also doing a lot of work outside, getting sort of face-to-face with the environment and trying to get a better scientific understanding of it. And what I think is really special too about earth science is that you can study the environment and the climate with all kinds of skills. So I have friends who are earth scientists who are interested in using engineering or math or chemistry, biology, even history to understand the earth and how it's changing. And it is really special to me to have all these colleagues with all different kinds of interests still working toward a common goal. So I thought I would show you a few of the places that I've been really lucky to get to go for research, just to sort of, to show you what my experiences have been. So I got to do some research in Wisconsin, where I grew up, taking samples from this beautiful lake in Colgate. We actually took our samples from a stand-up paddleboard, which you can kind of see there. And then on the right, this is a beach in New Zealand where I was really lucky to do a survey of the seismological characteristics. One of my favorite trips I ever got to do was going to central British Columbia, Canada in February. So it was really, really cold, but I had an awesome time taking samples from, you can't even see it, but under the snow and then the ice, there's a lake here. And we were able to take samples that give us a little bit of information about what life might look like on Mars. So if it's there, which we're figuring out with our new rover right now. So that was really wonderful. Now living in California, I feel really lucky to be close to all kinds of amazing earth science. So I got to go to Death Valley with a class and look at some of the oldest animal fossils on Earth. On the right, I am recently working on a project looking at the burn scar from, some of you may have heard that California had a record fire season last year, including the Bobcat fire, which was one of the biggest fires that there's ever been in the Los Angeles area. And so I've been taking some samples from there in order to understand how the fire changed the characteristics of the soil and the life that lives in the soil. And then some of the places I'm going to get to go as soon as the pandemic is under control that I'm really excited about is, well, first the Dangermont Preserve in California, which is this really beautiful nature preserve that has lots and lots of different environments, from the beach and the bluffs all the way up to the mountains and forests. And so studying all kinds of different biomes within a very small area. And then also I'll be doing some work on permafrost in central Alaska. So I just thought I would give you an idea of what this work can look like and how it allows you to be lucky and have all of these really amazing experiences before we get started with our conversation. So that was what I was hoping to share with you before we got started, but now I'd love to hear what questions you have for me.
Great, so I'll be kind of organizing the Q&A portion of this. So fellow teachers, Mr. Goodson, Dr. K, and Ms. Countermine Sub, if you could help me and help the students to ask questions out loud, that would be very helpful. So our first question comes from a lot of different people. So Grace, Julie, Ella M, Franny, Mia B, Chloe, and Brooke all gave a shout out for this question, want an answer to this, and Kira is going to ask our first question. So Kira, if you could come up to your board, ask the question in your wonderful crazy hat.
What made you decide to become a geobiologist?
Awesome. Thank you, Kira, and I love your hat. So I know I gave you a little bit of background, but when I started taking science classes in college, I realized that I really liked chemistry and biology, but I wanted to use those tools to understand big environmental processes that happen over the whole planet or over Earth's history over millions and billions of years. Because geobiologists look at the environment not just from the perspective of today or even the next 100 years, but the perspective of the whole history of Earth and evolution, and understanding how life and the relationship between life and Earth has changed over billions of years. There's so much we can learn about Earth's past, even that can tell us about what Earth might be like in the future. And so a lot of people really like the example of the dinosaurs, which some of you might be familiar with, thinking about how did the dinosaurs die and what can that tell us about catastrophic changes in Earth's environment. But one of my favorite topics that initially got me really interested in geobiology was actually thinking about the evolution of plants. So on early Earth, over 4 billion years ago, there weren't any plants around. And then as Earth continued to develop, there were algae in the ocean that could do photosynthesis. But when the first plants actually moved onto land and grew on land, it created these huge changes in the environment. And one example is those trees that were suddenly growing on land took up so much carbon dioxide from the atmosphere that it actually caused the whole Earth to cool down. And so learning about things like that just really made me interested to get into this research field.
Okay, so our next question comes from Claire. Claire, come on down.
What does one day at your job look like?
Awesome. Yeah, so kind of like I mentioned, one thing that I really love about my job is that it allows me to do all kinds of different things, even in just one day. So an example of what my job might look like for a day if I was on campus. So pre-pandemic time, I would go to campus in the morning. Maybe I would have a meeting with my research advisor or with some of my colleagues about what I want to do that day to make progress on my research project. Then maybe I would go into the lab, do some chemical methods on the samples that I'm working on in order to prepare them to make some measurements. After doing some preparation, I could take those samples downstairs where we have all of our big machines, our sort of research instruments, and they almost look like big like washing machines with all crazy wires coming out of them. That I use to measure my samples and understand what's in them and what they can tell me about the environment. If I had some time in the afternoon, maybe I would read some research papers, articles that other people have published that can help me better understand my research field and how to interpret my samples. Or maybe I would write in order to share the results of my science with other people. Sometimes in the afternoons, we even have seminars where speakers, researchers from all over the world will come and tell us about what they're working on and what their ideas are. And that's one of my favorite things, is to understand like what is the cutting edge of what other people are doing with science, and having conversations after those seminars with the person who comes to talk or with my colleagues, just to really get excited about these new ideas is one of my favorite parts of my day. But so another like totally different day would be a day that I'm actually like out doing research in the field. So in that day, maybe we're camping in tents, or maybe we're staying in a hotel nearby, and we'll get up, eat breakfast, get up early and plan what we want to get done that day while the weather is still good. Go to our research site, like scope out the site, use a drone sometimes to take pictures and get a really good overhead view and look around, take all kinds of measurements and observations, collect samples, take really good notes. And then once we've gotten the samples we want to do for the day, we'll take them back to our like base camp or our hotel and do what we need to do to process and preserve the samples so we can bring them back to the lab. And then get an amazing night's sleep because we're so exhausted at the end of the day. So yeah, those are just like two examples of a day in my job.
It's awesome how one day will look entirely different depending on where you are and your goals for that period of time. Awesome. So our next question is coming from Brooks, and Grace also said that she's interested in hearing this answer. So Brooks, if you could come on down.
What is your favorite part of your job?
Awesome question. Yeah, so I think this really goes back even to when I wanted to go into music, because I really couldn't see myself enjoying a job where I was sitting still all day long. And so I was really interested in doing something where I could use my hands and interact with something, whether that was a musical instrument or now like working with my samples and actually, being able to do all kinds of tests, walking around the lab. But what I think is really special for me about this job is that I can use my hands and I can use my brain. So I never, ever feel bored. And the ability to, to be able to actually like touch the science that I'm doing, to go outside and be face to face with it is really special to me.
Nice. All right, so our next question comes from Emmy, and Lara, Kira, and Claire also agreed that this was a great question. So Emmy, I'm going to have you come on up to the board.
Do scientists agree on climate change?
I'm really glad you asked that question, because there are definitely some news sources that might try to say this is not the case. But I want to tell you that all scientists who have qualifications in earth science and climate science agree that the climate is changing because of human actions and because of the greenhouse gases that human activity is putting into the atmosphere. So all scientists who have like legitimate qualifications and are not trying to trick people, we all agree that the Earth's climate, the temperature is rising, and extreme weather events are becoming more frequent because of that climate change. The thing that scientists are still trying to figure out is exactly how much the climate will change. And that depends on us getting even better measurements, doing even better predictions and computer modeling. And a lot of what the effects will be in the future also depends on what decisions humans make over the next, near future. So there definitely still is some room to learn even better what climate change exactly will look like in Earth's future. But we all agree that, in fact, Earth's climate has already changed. So in California, where I'm living, we already know that there have been more drought events and more wildfires over the last decade than ever in like recorded human history in California before then. So there's changes already happening, and we know that we know why it's happening. It's because of greenhouse gases.
All right, so our next question comes from Lila, and Franny, Valentina, and Grace also agreed that this was a great question. So Lila, come on up and ask your question.
How does climate change affect the oceans?
Yeah, so sorry, there's some siren sound in the background, so I hope it's not too distracting here. But this is a question that a lot of the time when I get to talk with young people, I know you all care a lot about, and maybe, some of you have a favorite beach that you go to near where you live, but there are all kinds of changes that climate change is having on the ocean, and it's something that I think we should care a lot about. So warming temperatures is an obvious one. We know that the surface temperature of the ocean is going up in most places on the ocean, and it's changing what animals are able to live in different parts of the ocean. And so we know that animals that prefer cooler temperatures, for example, are moving more and more northward in the ocean in order to get those cooler temperatures that they want. And in fact, that's actually changing the places where people look for different kinds of fish for fishing for their livelihoods. And so those warming temperatures are also changing microorganisms like the ones that live in association with coral reefs. And so some of you might know about the problems that coral reefs are having, and those are because of the warming temperatures. But another side of things is also the increasing carbon dioxide in the atmosphere goes into the ocean too. And so it's not only causing warming temperatures, but it's also changing the chemistry of the ocean water. And one of those changes that's happening is it's making the ocean water slightly more acidic. And so the acidity in the ocean water is another thing that's really affecting the organisms that live there, especially the coral reefs. And so there's lots of important effects of climate change on ocean biology. But it's also just changing the way that the ocean physically behaves. And so these changes in temperature are in some places affecting the way that the ocean water circulates and moves around. And so that's contributing to changes in weather patterns all over the world. It's also changing storm tracks. So we know that there are changes now in the ways that storms like hurricanes behave, partly because of the way climate change is affecting the ocean and the ocean water and the temperature of the water. And then finally, climate change is raising sea level because it's slowly melting the ice that is stored currently on land, both near the North Pole and in Antarctica near the South Pole. And as that ice continues to melt, it's going to continue to increase sea level.
Okay, so our next question comes from Lexi N, but unfortunately she had to leave a little early. So Sydney is going to ask this question for her. Sydney?
How did scientists find out that carbon was changing the climate?
Thank you. Yeah, I really love this question because it kind of comes down to even what I do in my day-to-day research. But something that a lot of people don't know is that scientists have actually had the idea that greenhouse gases like carbon dioxide are changing Earth's climate for over 100 years. So there was a scientist over a century ago who just did like math on a piece of paper because he knew some of the chemical and the physical properties of greenhouse gases. And he was able to predict that as humans were continuing to burn fossil fuels and release those gases like carbon dioxide, he could do just with a pencil and paper a prediction that those gases were going to trap heat in Earth's atmosphere. So that idea has been around for a really long time. But of course, as science has continued to advance, we've developed all these different ways of testing that idea and really showing that it's true. And so one example is that there are observatories all around the world, including a really famous one in Hawaii, where researchers have been continually measuring the carbon dioxide concentration in the atmosphere for many decades. And they've been able to trace that as the carbon dioxide levels increase in the atmosphere, they're really exactly matching the increases in Earth's temperature. There are also scientists who do all kinds of different experiments. So you can make measurements in a lab using different analytical instruments like the one that I use in order to really show that these gases are more likely to trap heat when they're in Earth's atmosphere. There are people who are still doing more and more advanced computer modeling, which is sort of like today's version of the scientists with a pencil and paper over 100 years ago, using concepts that from physics and math and chemistry that we know and making more and more precise predictions of how those will play out in Earth's atmosphere. And then finally, people like me who are geobiologists and like to think about Earth's history like to dig up all kinds of clues that are stored in the geological record, things like fossils, things like the chemical composition of rocks that has changed over time. And so we're able to use those clues like a detective to look into Earth's past and see how carbon dioxide and other greenhouse gas levels in the atmosphere have changed, millions or hundreds of millions or even billions of years ago, and understanding how those changes in Earth's past also impacted the climate. And so one thing that I think is really important to talk about is that we do know that Earth's climate has changed really significantly in the past, and there have been changes in greenhouse gas concentrations in the atmosphere in Earth's history, and we know those have changed the climate. But what's really different about human-caused climate change that's happening today is that those greenhouse gas levels in the atmosphere are changing way faster than they have really at any other time in Earth history. And so we're trying to use those examples from Earth's past in order to get a better understanding of what our future might look like and how the environment might respond. But we know that from all of these different ways of measuring, that it's human action and fossil fuels that have changed the composition of the atmosphere and changed the climate.
Hey, awesome. So our last question is actually my favorite question, and it was endorsed by Abby, Sydney, Ella P, and Lexi N. And it will be asked by Sloan, who came up with the question. So Sloan, come on up to your Promethean board.
If we make lots of progress in stopping climate change, what will the future of the Earth look like?
Yeah, I love that question. And I especially love that question when I have the honor of talking to people your age, because I think it's already really clear that young people are going to be so important in fighting climate change. We know that all kinds of people your age are really concerned about what Earth's future is going to look like, and they're speaking up and using their voices, and people are listening to them. And there are people in the world who are already sort of responding and understanding that young people care so much about the future and are starting to make changes to policies in order to protect our environment's future. And so, like I've sort of been mentioning throughout our talk today, we already know that the climate is changing right now. We know that Earth has already warmed some, and that extreme weather events are getting more common and more intense. But where we are right now, we still have the ability to slow down climate change in a way that will enable us to still adapt to the future changes that we know will happen. And so if we start if everyone teams up now and starts working really hard, we can still create a future where, even though we can predict that, that the weather will change, that it'll change the way we can grow our crops and the ways that we protect ourselves from storms, we still have time to slow things down so we can adapt, we can prepare for those changes, and we can meet that challenge. Because something that is so clear from studying all of Earth's history is that life is really good at adapting. And changes in Earth in the past have caused life to adapt and evolve and find a way to continue thriving. And I feel really strongly that if we decide that this is something we are going to face head on, we absolutely still have time to fix it and adapt and to create a future where all of us are safe and our environment is healthy.
Thank you so much, Hannah, for answering our questions. And I did want to thank you guys, the students, for coming up with so many great questions. It was really interesting cycling through them and deciding which questions to focus on for this talk. So you guys did a great job. Thank you so much, Hannah. My friends, if we could give another round of silent applause for Hannah. All right. Thank you so much, Hannah.
Yeah, and thank you all so much for your wonderful questions and just for bringing your curiosity and your energy today. And I hope these are things that you continue to think about going forward. And yeah, thank you so much for having me.
Thanks again, Hannah. We really appreciate it. Carving time out of your day, listening to your days now.